question. It says select the graph that shows the solutions to the system of linear inequalities. So it's a multiple choice question. We have A, B, C, or D here to choose from. What's the right answer, guys? Right now? I'm going to find it. I think it's actually D as in dog for this question. D as in dog. Let's talk about how we could figure this out. All right, so looking at the lines themselves, they look identical, correct? The only thing that's different is the shading. So if you remember back to inequalities like this, the shading is a solution, right? Each of these graphs is representing a different region. Now, if they're each representing a different region, if I pick a point, say, from letter D, I know it's right, then it should work in both of those inequalities, correct? If I pick an ordered pair in the shaded region on C, or in the shaded region on A, or in the shaded region on B, if I pick an ordered pair from each of those in the shaded region, they shouldn't work in both inequalities, correct? They work in one but not the other type of thing. D is the right answer. We know that's the right answer, so I'm going to show you why it does work. So on letter D, let's pick the ordered pair. I'm going to make this easy. I'm going to pick 3, 3. It's in that shaded region. When I test it, it should work in both of the inequalities. So 3, 3 is what I'm testing. If I put 3, 3 into the first inequality, 3 is less than or equal to 2 times 3 minus 2. 2 times 3 is 6. 6 minus 2 is 4. 3, 3 worked in the first inequality, correct? So if I try 3, 3 in the second one, three is greater than, this is going to be negative 12 plus 4, that's negative 8. And that's true also, isn't it? Isn't 3 greater than negative 8? Okay, so algebraically, D is correct. Let me show you that you could type this into your graphing calculator. Again, on the EOC, you guys are all going to have access to a calculator. I'm not sure which one, there's some new ones and some of the old ones, but you will have a graphing calculator. They essentially do the same thing. You know, to type them in, it has to be like a y equals, okay? And we've got that in both of these problems. So let's look at our graphing calculator. Go to y equals, please. If I'm typing in the first one, I want to arrow over, let's see, let me change. Okay, so the first inequality was, the first inequality was less than, correct? So we would want to shade the left side to make your graph do that. Less than, we want to shade the left-hand side. So I'm going to go to y equals. I want to be over here on the far left. Do you see where my blinker is? It's on the left side of that y sub 1. And I'm going to, I think on yours, I think you can just click enter, and I think it'll change it. Let me show you what I'm looking for here. I'm looking for this right here. Do you see how it's shaded on the left-hand side of a line? That's what I'm looking for. Were you able to find that on your calculator? Okay. So I'm going to hit OK. And then I'm going to go down to y sub 2. And let's type in that equation. That one was negative 4x plus 4. Whoops. I'm going to go over here to back to my shading portion. I can change this now. And I want to have the greater than, we're going to shade on the right hand side. Greater than, less than left, greater than is going to shade on the right. So if I hit enter, for you guys you should be able to hit enter and go to the next one. Keep hitting enter till you get the one you want. shadings on there. Go ahead and click graph. If you're having trouble, let me know and I can help you with it. Nothing, okay.
Just like turning off.
Ah, that's fine. Where's this? Oh, this keeps running off. Oh, you get another calculator. I bet your batteries are dead. Okay, so mine appears in color and it's easier to see, but do you see what I mean that it matches letter D? Okay, and of course we could do all this algebraically. We could do all this algebraically if we needed to. Anybody having trouble getting it to come up on their graph? Anybody else have trouble? Okay, so do me a favor before we get out of this. I want to clear the memory so that if somebody else uses this calculator, they're not going to have shading, you know what I mean? So let's get rid of that. I'm going to show you how to clear your memory. You can title today's notes 8-5. Today's factoring method is called difference of squares. Difference of squares. Hopefully you guys all have a calculator. We're going to start, we're talking about what the phrase difference of squares means. When I say difference in math terms, what does difference mean? Subtraction, that's right. So difference of squares, we're going to be factoring binomials, means two terms today, and we are using a difference of squares. So we're going to have subtraction. In squares, when I say square, what power did you think of? To the second power. So we're going to have perfect squares. To begin this lesson, I want to make a list of common perfect squares. Put this somewhere handy on your notes page because I think you're going to want to reference it. Alright, so perfect squares are numbers that I take to the second power. What is 1 squared? 1. 1 squared is 1 times 1, or 1. So 1's a perfect square. 2 squared is 4. 3 squared is 9. So I'm implying that 1, 4, 9, these numbers in the right-hand column are my perfect squares. What is 4 squared? 16. 5 squared? 25. Please make a list of these in your notes. I think it will be helpful for you as we go through today's lesson. 6 squared? 36. What is 7 squared? 8 squared? 64. 9 squared? 81. 10 squared? 100. 11 squared? That's right, 121. 12 squared, anybody know that one? 144. Anybody know 13 squared? You can use your calculator if you need to. 13 squared. 169, that's right. How about 14 squared? 196 is correct. 15 squared? 225. Let's see. That's probably far enough with our numbers. So we could go further. We could go 16 squared, 17 squared, 18 squared. What's 20 squared? 400. runner, you could add that one in if you wanted to. This is just a partial list of perfect squares, isn't it? Not a complete list, we could obviously keep going. So if you see any of these numbers in the right-hand column, 1, 4, 9, 16, 25, 36, 49, 64, etc., those are perfect squares. Now, perfect squares don't have to appear in number form. They could appear in variable form. Let me show you what I mean. A squared is a perfect square. So is b squared. In addition to that, I could have c to the 4th power, or even d to the 6th power, e to the 8th power, f to the 10th power. A variable with an even power is considered a perfect square. A variable with an even power is considered a perfect square. To be a perfect square, that means a number times itself would give you this number. For example, f to the 10th. If I take f to the 5th power times f to the 5th power, doesn't that give me f to the 10th power? Okay. When we multiply variables, we add their exponents. So is it d cubed times d cubed, d to the 6th power? And e to the 4th times e to the 4th, e to the 8th? C squared times c squared is c to the 4th? Okay. These are also perfect squares. Difference of squares basically uses a formula, and I'll show you on the next slide what my formula is. One more. It's right here. You're going to have some kind of perfect square minus, like that would be b squared, some other perfect square. A perfect square minus a perfect square. To factor that, what we're going to do is set up two parentheses. One of the parentheses is going to be a minus b, and the other one's going to be a plus b. So it's going to be a perfect square minus a perfect square. And we're going to factor it like this. To get a and b, I'm just taking the square root of a squared and the square root of b squared. That's how I get a and b. Let's look at a couple of examples. In this first example, we have m squared minus 64. Do we have a perfect square minus a perfect square? Okay. Yes. Is it m squared a perfect square? Is it a variable to an even power? Is 64 a perfect square? It was on our list, wasn't it? Okay, so we do have a difference of squares here. So I want you just to set up two parentheses side by side to show that we're multiplying. One of the parentheses is going to be a plus sign, the other is going to have a minus sign. It will always, 100% of the time, work this way if we're doing difference of squares. To fill in these empty spaces, I'm just going to take the square root. What's the square root of m squared? M, simply m. What's the square root of 64? 8. Or in other words, here's 64. What did I square to get 8? Or get 64? I squared 8, didn't I? Okay. So one factor is going to be m plus 8. The other factor is going to be m minus 8. That's it. How could I get back to the original problem? Foil it. Now I want to show you something real quick, guys. If I was to FOIL this, I'm going to get m squared minus 8m plus 8m minus 64. Okay. Look at these middle two terms here. What's going to happen to these middle two terms? They're going to cancel out. You know what made them cancel out? The signs. The fact that one was minus and one was plus. That's what's going to force them to cancel out. And I'm left with m squared minus 64, which is what we started with. Okay? Let's try another one. X squared minus 81. Do we have a perfect square minus a perfect square? We do. We have a difference of squares. So let's factor by setting up two parentheses side by side. We know that one parenthesis is going to be a plus and the other is going to be a minus. And it doesn't matter if I flip-flop that minus and plus. It doesn't matter. So what's the square root of x squared? X. So we're going to leave with x in both parentheses. What's the square root of 81? 9. 1 is x plus 9, 1 is x minus 9. This is my factored answer. Now once again, I want to show you if I FOIL this, and I can do that really quick. What's going to happen to those middle two terms? They're going to cancel. What causes those middle terms to cancel out? The signs. We will learn in Algebra 2 that these are called conjugates of one another, and that will happen every time. How about this one? 16y squared minus 81z squared. Do I have a perfect square minus a perfect square? Yes. 16 is a perfect square, so is y squared. I've got my minus. 81 is a perfect square, and so is z squared. No big deal, there's a coefficient. Let's go ahead and set up our factor form. We know one parentheses is going to be a plus, and the other is going to be a minus. Just take the square root. What is the square root of 16y squared? 4y. So we're going to leave with 4y. What is the square root of 81z squared? 9z. We're going to follow up with 9z. Now, in this next slide, it's a little bit different. Look at this one with me. 3b cubed minus 27b. Do I have a perfect square minus a perfect square? No, 3 is not a perfect square, neither is b cubed, 27 is not, neither is b. What could we do? We can use one of our factoring methods. Anybody know it? Yes, greatest common factor. Do you see that? What can we take out of both of these terms? What else? 3b, very good. So write 3b. Now when we do greatest common factor, how many parentheses do we have? Only one. Difference of squares, box method, easy method, we're going to set up 2, grouping will end up with 2. But greatest common factor, we just have one parenthesis with their greatest common factor on the outside. So I'm applying greatest common factor right now. I'm dividing each of these terms by 3b. When I divide by 3b, what do I end up with? b squared minus 9. So in this case, we factored out our 3b. Look at what you have left inside that parenthesis. Don't we have a perfect square minus a perfect square? Okay. Let's factor this. Let's set up a difference of squares. Is that a perfect square minus a perfect square? I know one of these parentheses is going to be a plus and the other is going to be a minus. What should I do with this 3b in the meantime? Just drop it down. That's right. What's the square root of b squared? b, so I'll leave with b in each parenthesis. What's the square root of 9? 3. So plus 3 and minus 3. This is my factored answer. Let's try another one similar to this. Do you guys have any questions on this one before I move on? We'll do this one next. 5x cubed minus 20x. Do we have do we have a perfect square minus a perfect square? I don't think so, because really none of these are perfect square. They would all have to satisfy the condition. It would all have to be perfect square minus perfect square to work. We don't, but we do have what that we can factor? Good. Greatest common factor, and what is our greatest common factor? Good. Let's factor 5x out first. Now, just as a reminder, greatest common factor is the only one where we have one parenthesis. So I'm dividing each of these terms by 5x. What is 5x cubed divided by 5x? X squared. What is negative 20x divided by 5x? Negative 4. Look at what we have in parentheses. We have a perfect square minus a perfect square, don't we? So let's factor that further. I'm going to set my 2 parentheses. We know one's going to be a plus and the other's going to be a minus, and I could have flip-flopped that plus and minus sign. And of course, we'll do what with that 5x? Just write it down. So what is the square root of x squared? So we'll lead with x in each parenthesis, and the square root of 4 is 2. We'll follow up with 2's in our parentheses. So our correct answer here is letter D. I've got a couple more that I want to show you. What happens when we don't have an exponent of 2? Like this one. If we have something like this where we have y to the 4th power minus 625. Now, y to the 4th power is a perfect square, right? We said any variable with an even power. Is 625 a perfect square? Well, you can easily check that on your calculator. Second, x squared, square root of 625 is 25. So it is a perfect square. So you could have done it this way. 25 to the 2nd power, 625. So let's do a difference of squares. We know one parenthesis is going to be a plus and the other is going to be a minus. What is the square root of y squared? Sorry, what is the square root of y to the 4th power? Y squared. I told you the answer, didn't I? Y squared. What's the square root of 625? 25. I think we can factor again. Does anybody see the spot where I can factor again? Which one? This one. In that parenthesis, the one I put a red box around, I have a binomial minus a binomial, don't I? Let me say that again. I have a perfect square minus a perfect square. So the wrong term. Correct? Do I have a perfect square minus a perfect square in the first parenthesis? I don't. I have a plus sign, don't I? So I can't do anything further to that first parenthesis. I'm just going to bring it on down. But the second parenthesis, I've got a difference of squares. A perfect square minus a perfect square. So I'm going to set up two parentheses and I'm going to factor again. We know one parenthesis is going to be a plus and the other is going to be a minus. What is the square root of y squared? Y. And the square root of 25 is? 5. I've got just a couple more to do with you. I'm almost done, guys. Let's do this one next. 256 minus n to the 4th power. Do we have a perfect square minus a perfect square? Is 256 a perfect square? What can I square to get 256? 16 squared is 256. So we have a perfect square minus a perfect square. Let's set up our factor form. We know one of the parentheses is going to be a plus and the other is going to be a minus. What's the square root of 256? 16. So we're going to lead off with 16. What's the square root of n to the 4th power? N squared. Can I go further with either of these parentheses? You agree that the second one can go further? This one that I'm boxing it in blue can go further. Why can't I go further with the first parenthesis? It's addition. We would have to have a perfect square minus a perfect square to go further. So first parenthesis, I'm just going to bring it on down. I can't do anything with it. With the second parenthesis, I'm going to break down into two new parentheses using difference of squares. One's going to be a plus and the other's going to be a minus. I put a flip-flop where that plus and minus are. What's the square root of 16? 4. We're going to lead off with 4. What's the square root of n squared? And there you go. There's our factored form. Okay, that's where I'm going to stop for today. In order to use difference of squares, we must have a binomial in the form of perfect square minus a perfect square. If we don't, maybe try greatest common factor. What if it's not factorable at all? We couldn't do anything, not even greatest common factor. What would we say? Prime. If it's not factorable at all, that means you can't do greatest common factor, couldn't do difference of squares, couldn't do anything, we would say prime. Today's homework is out of your textbook. If you don't have a book, go ahead and grab one real quick and I'll write the assignment up here. This may go on to the next page. Does anybody have their book there yet? 501 to 502. I think it's 501 to 502. Numbers 1 through 8 and 16. 1 through 8 all, and 16 to 34 even. Is that yours?
Yeah.